So I have aligned the layout of the screen. Now let us try to create the 2D sketch of this and revolve it with respect to the horizontal axis of revolution. So it is a very simple task. Please do not get confused with respect to this. So first job is to click on the revolve option and select the front view. Now we have to align the view with respect to the normal to the screen. And after this, we have to create a center line. We have to use the datum or the global datum and we have to place it horizontally. Now this line will be designated as the axis of revolution by default. Then we can try to select a sketching center line and we can create a vertical line. So the center lines are created for maintaining a symmetry. And again, I'm going to simplify my job. So I will be working only on the left hand side first. And I will be mirroring the left hand side on the right hand side. So let us first create the base line. And we have to decide whether we are going to work on the upper side or the lower side. As we have selected the horizontal center line as the axis of revolution, we have two options. Either we can work on the upper side of the center line or the lower side. Looking at the figure, it is quite better for us to work on the lower side because we have the dimensions and the alignment, the orientation with respect to the lower side. So it is better for us to work with the lower side. Now first I will be creating the base and the width of the base is equal to 100 units, which is mentioned over here. So please analyze the dimensions which are present. So I'm creating a symmetric base of 100 units and the diametric distance is 40 units. So I'm automatically getting a diametric dimension over here because I have assigned a global datum center line. So I just have to change the diameter to 40 units. So the first line is done. Now we have to go down and we have to stop at a location where the diametric distance is equal to 70 units as seen in the figure. Done. So we are done with this work. Now we have to go to the right hand side. Stop at a location, just zoom in. Stop at some random location. Clear. And do I have the distance for this? Analyze the geometry. Yes, on the right hand side you can see that we have a distance of 10 units present to us. So I'll just double tap on it and change the dimension. Now I need to go down and I need to create a slanted line. So I'll just click on line segment. So randomly you can create a line at any distance and then we can modify. So that is the best part of Creo Parametric. So first thing is, let me modify the diametric dimensions which are automatically generated over here and it has to be 140 units. So I'll double click on it. So the distance have been changed. Now I need to maintain the distance of 44 units which is present over here, and that is from the outer edge of the base to the point at which we have stopped. So that is equal to the dimensions of this point and the outer point. So this is equal to 44 units. So now I have adjusted the position of this slanted line. So we basically got the kind of Y shape ready with us. So let me just click on line so that the dimensions are disappeared. And we can see that we have formed this shape right now on the screen. So the next task for us is to create the vertical line. So for this I'm using the line option and continuing my line segment and adjusting the diametric dimension, that is equal to 360 units. And this is automatically generated over here. So I have changed the dimensions right now. So far we have created the section which is clearly visible for us, and the dimensions of this sections is present in the detailed view over here. So now I have to work on this dimensions. So let me just maximize the photo or the picture and let us see the three-dimensional view over here. So we have the total diameter of the friction wheel which is equal to 400 units, and till this point the dimension was 360 units, or the diameter was 360 units. That means from the center axis to this particular point, the farthest edge, the diameter has to be 400 units because it is mentioned in the three-dimensional view. Clear? So we are progressing in a correct way so far, and this also indicates that the distance or the length of this particular edge has to be 400 minus 360, that is 40 units, divided by 2, because this will be 20 and on the other half we will be having 20 units. So that is the reason I'm just dividing by 2, because from this particular point to this particular point it is 400 units as seen in the three-dimensional view, and from this point to this particular point it is 360 units. So this has to be around 20 units. Clear? So let me just minimize it again and zoom it to the detailed view. So now we are at a position now you can move to the left. We can create a line segment, and on a closer observation we can see over here that these edges are rounded, but I'm not going to follow this rounding dimensions over here because these are not mentioned over here properly. We are trying to learn the revolve option, so I'm just sticking to the edges, the sharp edges right now in this particular case. So we can move to the left, and the distance is almost 20 units which is present in the base over here. So we can just move 20 units to the left. Now we can go down 20 units again. So if I can verify in both ways. So firstly let me verify what is the diameter, the total diameter. Let me adjust it to be 400 units because I mentioned that the total diameter of the wheel is 400 units. Now I can verify the distance of this segment. It is 20 units. So the discussion what we have done so far was correct. This is a small verification. Now we can go 10 units inside because this distance is equal to 10 units. It is present over here and present over here as well. $10 units, and I need to go inside at a depth of 10 units again. So I can just click on the edge and change the dimension to be 10 units. Then I can go inside and stop it at a position, and the distance from the outer edge till this position is 20 units. That means 10 and 10. So this is 10 units and this is 10 units. The total is 20. Now I can just go down and stop at the position where we can continue our line till the vertical axis. So this has to be, so the sketch what we have created so far is the left hand side of the hatched region over here. Clear? Now we can just mirror it on the right hand side and we can sweep it or revolve it around the axis. That is the horizontal axis. So let me just press escape button and let us select the segments. So I will be very careful over here because sometimes there is a possibility of selecting a segment twice and re-sketching or mirroring the same segment by overlapping it on the segment what we have created. So we have to be very careful when we are mirroring, because if we are mirroring the same segment twice, then we will not be able to form a closed loop and we will be getting an error message. So I'll be just selecting very carefully the first and the second option or the segment by holding the control key. Click on mirror and the center line. So we got this edges. I'll select 1, 2, 3, 4 and 5. I hope all are selected. Looks good so far. Now we can select the vertical segment, mirror it on the other side. I really hope everything is working smooth at your end. Yeah, so there is a problem over here. So let us verify the problem, because we are not getting a shaded region over here. Maybe, as I was mentioning, I have overlapped any of the two lines. So let us start looking from the base. So each of the constraints should be twice. I mean, we should have a constraint. If the constraint is on the left hand side, it has to be on the right hand side only single time. So this constraint is for the horizontal line. This constraint is for the vertical line, I believe. Yeah. And we have additional constraint over here, the mirror option. You can see there are 3 options over here. So these 2 are for the baseline and these are for the vertical line. There is one more additional. I believe I have created a line over here. So let me just delete it. I'm sorry. Let me delete one segment over here and one segment over. See, I got twice over here. So you have to be very careful in this particular case. I'll just create a segment over here and I'll just join it. Now we have the shaded region over here. So please be very careful, and I'm really happy that we are getting certain problems when I'm working over here, because we are also able to understand the procedure for solving those problems. So now that we have created the 2D sketch, the next job is to just sweep it by pressing OK. So automatically I'm getting the wheel, and this has been revolved right now. So you can see the complexity with respect to the figure which is given to us at first glance was very high, but when we were understanding the total geometry, the sections and the views which is given to us, we have come to a conclusion that sweeping the shaded region is going to give us a revolved geometry. And we have followed the same procedure. We have created the revolved section by utilizing these dimensions, and we have created the friction wheel. So let me press OK right now. So we're not done yet. We have some things left over here. We have to create holes over here, and we have to create a slot over here. So for creating holes, we can create on the central plane by using the extrude command and removing the material. So you can see there are 5 holes over here. Each is having a diameter of 75 units. So let us try to create the first hole. So in this particular video, I'll be showing you procedure for a new option called pattern, wherein we can generate multiple number of holes at one span. So for this, first we have to click on the or generate a hole first. So do we have any distance given to us? So the center of the hole is placed at a location of 248 diameter. So we need to just change the display style. Let me delete this circle what I've created. So let me go to construction mode and use the center circle and create a construction circle. So this construction circle is just for reference, and let me adjust the diameter of this construction circle to be 248. On this construction circle, I need to create 5 holes. Clear? So I'll just go back to the normal mode, click on the circle and generate a circle of 75 mm diameter. So let me first create a hole of 75 mm diameter. Before that, let me change the display style to shading, and I will be using the symmetry option. I got a hole over here. Let me press OK right now. So but in the figure we have, or in the geometry which is given to us, we have to generate 5 holes over here. So there is an option called pattern, with which we can generate the same feature n number of times. Okay, I'll just show you the procedure for it. So first we have to select the feature what we want to pattern. So I'm selecting the feature, that is the extrusion command or the extruded hole over here. So you can see the pattern option over here. It is in the editing option, and this particular option is not highlighted or shaded. It cannot be used until unless the feature is highlighted over here. So I have to select the feature which I want to pattern first, and the moment I'm selecting the feature, I am getting this option activated. I have selected the option, and now I have to click on axis. So I will be showing you the other options in the future videos. So right now we have to select the axis command, and we have to select the central axis of this particular wheel. And the moment I'm selecting center axis, I'm getting 4 points. So this will represent the feature which is getting patterned over here. So I'll be selecting this option, that is 360 degrees, and I am wanting 5 holes over here. I need to press OK over here, and the moment I'm pressing OK, I have the 5 features ready with me. So I'll just repeat this in the next video as well.